I have the honor of moderating the panel today. We have a number of distinguished panelists, and I'm going to introduce them in a while. But before we start with our panelists, we are also very fortunate to have a very special guest as the keynote speaker for our panel, Dr. Moniz, the Secretary of Energy in the United States. Dr. Moniz doesn't really need a lot of introduction. He's been a leader in the energy field as well as nuclear energy field for a long time. He currently serves as the Secretary of Energy in the U.S. administration. He implements the critical energy missions at the Department of Energy, encompasses advancing the President's all of the above energy policy, maintaining the nuclear deterrent and reducing the nuclear danger, promoting American leadership in science and clean energy technologies, as well as cleaning up the legacy of Cold War. Prior to his appointment in the administration, Dr. Moniz was the Cecil and Ida Green Professor of Physics and Engineering Systems at Massachusetts Institute of Technology, MIT, where he was a faculty member since 1973. Without any further ado, I would like to introduce Dr. Ernest Moniz.
Well, thank you, Kamal, and also greetings to the panelists. I'm really pleased to have the chance to come here to the COP and have a chance to discuss nuclear energy, nuclear power, as one of the essential elements of the low carbon portfolios, certainly not everywhere, but I think in many parts of the world, and I'm certainly hoping as well in the United States in terms of a continuing major contribution to low carbon. Here in Paris for this COP meeting, where obviously a critical negotiation is going on for setting the pathway to a very low carbon future. I think it's important to remember that as we look at solutions for climate change, for mitigating the risks acceptably, I think there are two elements that are certainly common to just about every reasonable modeling of that future. One is there clearly has to be a very significant demand-side contribution, energy efficiency, conservation, and the like. Behavioral change may be a part of it, but certainly we will have to have very strong demand-side contributions. But secondly, as we go to a low-carbon future, just about any, again, modeling of that future has decarbonization of the electricity sector as kind of a leading element. In electricity, we have a lot of options. We have stationary sources. We all know the reasons why, in fact, those are kind of two common elements in a low-carbon future. Then if we talk about a decarbonized or a largely decarbonized electricity sector, obviously nuclear is, and I think many of us think must be in the future, one of the main contributors to that portfolio, where the options are fundamentally renewables, nuclear, and carbon capture. So I think nuclear is very important. Now, as we, in my brief remarks today, I want to talk in terms of kind of a few time scales, in terms of the nuclear issues that we address for deployment in those time scales, although I want to emphasize action is required on all elements of the program now and in the near term. Certainly, when I think of time scales, we all can, I guess, choose our favorite demarcation time. I will say 2030 stands out to me for a number of reasons. First, a critical feature of this COP meeting is the fact that we, the world, came into this meeting with INDCs, with national targets for almost every country of the world, and most of those are in a kind of a 2030 time frame in terms of targets. So that's an important point. We can discuss what comes after 2030, of course, but 2030 is where I think the targets being set today typically have a time horizon. Secondly, if we go to the United States, in many ways, well, certainly a very central element of the President's Climate Action Plan is the Clean Power Plan. And that again has a kind of a 2030 time frame where a 32% reduction is the target in the Clean Power Plan. And finally, if we go to the nuclear enterprise, if we take 60 years as a typical lifetime for reaction. Now, we'll talk about, of course, the possibility of an even further extension, but we know already that 60 years is a very, very, very credible. In fact, we are seeing it in front of us in terms of licensing of reactors for 60 years. Well, then, simple arithmetic and the schedule of building reactors tells you that 2030 would be the time then to start a very substantial wave of retirements at a 60-year mark. And so, once again, it's a very important time period. Either we will have another life extension period for the majority of the fleet, or we're going to be in the business of replacing a lot of carbon-free power at that time frame. So again, that kind of gives me a little bit of a reference frame, at least in terms of how I think about it, and remembering that in the carbon discussion, once we at 2030, maybe we can take a little bit we can exhale and then get right back to the job of even more stringent requirements as we go forward in terms of decarbonization. So in that context, I kind of think of maybe a near-term and then an intermediate term up to 2030, and then a longer term. Certainly in the near term, a critical issue that we are facing is that of maintaining the existing fleet, where I'm not talking about pressures from reaching 60 years. I'm talking about pressures from natural gas prices and other issues in the marketplace. Just as a reference, a numerical reference, a retirement of roughly a third of our nuclear power plants is the equivalent of about 100 million tons of CO2 per year. So it gives you a scale that if we have retirements that are significantly beyond those we're seeing already, we have a big carbon hit. And that's even assuming natural gas as the primary replacement for for nuclear power. So clearly the issue of the operation of current plants is very important. As we think ahead to the medium term and 2030, I think that it is critical that the utilities understand with sufficient lead time before 2030 what they can include in their capital plans for meeting the 2030 and beyond. And so that means maybe we have 10 years, that's a little bit optimistic, to really establish a set of options for going forward. So that would certainly include the issues of completing and understanding what's happening with our current advanced generation 3+, let's call it, of reactors, where we have 4 being built in the United States. We have quite a few more being built in China, and understanding cost and schedule performance and where we can go with those as we build more of those is going to be very critical for decisions to be made. We also, certainly in the United States, but in many other countries, we really need to understand, in my view, really understand the performance of small modular reactors. I mean, I'm talking now about those based upon light water technology in the sense of getting one or more. I know we will have a discussion on the panel of NuScale in particular, heading towards design certification submission to the NRC next year, and we need to start seeing, you know, real things happening early in the next decade if we're going to have that set of options available on the time scale that I mentioned. I should say in both of these time scales, including the short one, another very important issue. It's relevant to the continuation of our current fleet. It's also relevant to the decisions that are going to be taken in terms of future capacity additions as to how our electricity markets are or are not restructured. We know that for example, all the services in the electricity system are not valued in a very sophisticated way, shall we say, and some of the important features of nuclear power, other sources as well, demand side programs as well. We just need to get to a better valuation system, and I think that will be important for nuclear power in particular, and certainly important for investment decisions that will be taken. Then there's a longer term where clearly we have to be investing in, I think, advanced concepts. We have to be investing in developing the infrastructure needed to think about advanced concepts in the United States. So lots of decisions in the relatively near term in terms of how we structure our portfolio for addressing these longer term issues. So I'll just say a few words about some of these points and leave it to the professionals on the panel to go into more detail. If there's time, I might just say a few words at the end in terms of the nuclear spent fuel, nuclear waste issue. I said it already, but let me repeat something on this question of, in the near term, understanding and evolving market structures. In April of this year, we published the first installment of the Quadrennial Energy Review. That was looking at energy infrastructure. Of particular relevance here today, I would say, is that our second major installment, which is underway, is on the electricity system as a whole, from end to end, from supply through demand side. And in that, what I want to say is right up front, we are very actively looking at this question of valuation, which we think is really central to how various supply, low carbon supply, is going to come into the system. So just want to say that is a special focal point right now in our energy policy work. How the Clean Power Plan implementation plans evolve in the states is going to be very important in terms of the incentive structures for existing plants. In my view, there's no matter how the Clean Power Plan goals were set, the implementation plans are going to have to look at the reality of nuclear power as low carbon source. So that will be very important, and I invite you all to talk to Gina McCarthy, who is here as well today, in terms of how they're seeing this happen. I might say that the Department of Energy is working in terms of a technical assistance mode, if you like, with states in order to help, in a technical sense, the development of SIPs, of the state implementation plans. In terms of moving forward, one of the things that we are doing as well is we have a light water reactor sustainability program. with research in partnership with the NRC and the industry to address aging materials, obsolescence of residual analog technologies, advanced safety analysis, a whole set of issues there, which we think, again, are important components of the question of addressing whether or not further life extensions, for example, will be in the cards. We also have a few years ago, 2010, DOE started a set of innovation hubs. The very first hub was in nuclear energy, Castle at Oak Ridge, developing large-scale simulation tools for the analysis of nuclear power plants and fuels, and that's been very, very successful. Another tool that I believe will be very helpful in looking at the safety and life extension questions. In fact, accident-tolerant fuels is another major focus in our program going forward. Fuels that address things like hydrogen buildup, etc. Obviously, the Fukushima accident has put, I think, a premium in terms of this kind of research program. The issue, okay, nuclear waste. I'll come back to nuclear waste a bit later. I think I'll leave that for the moment. Going to the modular reactors. Again, I'm not going to say too much because I know in the panel we'll have a discussion. But I just want to say that we remain very bullish, certainly on the imperative of advancing small modular reactors to the point where we can really all understand not just their technical performance, and we certainly see these reactors as having excellent characteristics, safety characteristics, etc. But let's face it, we are going to have to understand what is the real world financial performance of these reactors, and especially to understand what will be the economies of scale as one goes to a scale-up of the deployment of these technologies. So that's something that I think we still have to work on, the scale-up part. But the first thing is to get the first group out there, and then we'll have to look at the scale-up. But I want to emphasize again what I view as the urgency of moving on this, because I think we need to have this option on the table, understood on the table, as those mid-decade, next decade decisions are going to be made for capital planning. In terms of the longer term, I think I think we need to, and I'm pleased to see that I think we are lifting our headlights a little bit in returning to looking at more innovative concepts as well in the nuclear arena. Now, one generic initiative about which we are tremendously excited is the one that was discussed here last Monday by President Obama and the leaders and senior government officials from 19 other countries, the Mission Innovation Initiative, in which the 20 countries, which collectively currently have, I would call it a quasi-public R&D budget, energy R&D budget of about $10 billion, those countries committing to a doubling of that over 5 years. So adding another, say 5 years from now, adding another $10 billion to the base of energy R&D annually, we believe will obviously open up the innovation pipeline and give us many more opportunities for that longer-term impact, where we're going to have to crank down very, very strongly on carbon, including, as I said earlier, essentially more or less decarbonize the electricity sector. The Mission Innovation announcement, I don't know how familiar everyone is, was accompanied by a parallel announcement of a private investor network put together mainly under the leadership of Bill Gates, in which investors from 10 countries are going to put billions of dollars on the table with the idea of investing with much more patience than is typical and with much greater risk tolerance than is typical. And so the idea is that they will be looking to invest in the products of this expanded innovation pipeline in the mission innovation countries. Now, nuclear has to be part of that. It's interesting that, of course, Bill Gates certainly showed that characteristic of investing with patience and risk tolerance in investing in TerraPower as one example of a much more step-out nuclear technology. And in the United States today, we have almost 50 companies with private funding looking at novel nuclear concepts, both fission and fusion. And I think this is, again, another direction that we need to go in. And with mission innovation, again, I at least feel very strongly that we need to see nuclear as part of that portfolio based upon very, very promising concepts. In terms of supporting private sector progress on nuclear, we announced last month the Gateway for Accelerated Innovation in Nuclear, or GAIN, and Kemal, where did he go? Oh, you're there, I think, is the director, I believe, of GAIN out at the Idaho laboratory, and the idea here is to provide the industry with access to technical, regulatory, and financial support to help commercialize new and advanced nuclear reactor designs. I think this is an important job for our national laboratories, and one that can only be carried out successfully, however, in collaboration with universities and the industry. Certainly looking at, again, ideas beyond light water reactor technology that may be important further down the road. So that's just kind of hopefully at least gives you an idea as to how I at least am looking at how the nuclear is fitting into the bigger puzzle in terms of a low carbon future, its importance. Maybe I will just add a word on the back end side, and to say that we will continue to advance what is fundamentally the set of recommendations made by the Blue Ribbon Commission a few years ago and endorsed by the administration, and that means that we will be advancing our consent-based processes, both for consolidated storage and for disposal. And on the disposal side, many of you may have noticed in the summer, the President issued a determination that we also now have the flexibility of pursuing defense waste and nuclear power plant spent fuel disposal on separate tracks, which I think is going to be to the benefit of both tracks, in fact. So I just want to say that in 2016, I expect that we will be moving out in this direction as well to address the back end challenges. So with that, I'm going to conclude. Again, I think that I've laid out kind of these three different sets of challenges over different timescales, but I want to end by repeating that the work on all of them has to go on now as we address these challenges for this decade, the next decade, and the longer term future. So thank you very much, and I'm sure you're going to have a very stimulating rest of the session. Thank you.
You mentioned TerraPower in your competition slate.
To do is introduce each panelist